We're now continuing with our work. We are doing revision on today's program. We are revising the work that you guys worked on in during the course of term 1. So we looked at a question that was based on sequence and series, and our next question is a trig question. We understand that you guys struggle a lot with trigonometry. So if you run into challenges while you are doing trig, use our app. Our app has got awesome videos that help you to cover your content from grade 10, grade 11, all the way up to grade 12. And it's also made possible by Liberty. A big shout out to Liberty, guys. They're doing an awesome job to try and help you with your education. While you are where you are, we are here for you to help you to see what is going on. So let's go to the next question, which is a trick question that is asking us to do a lot of very exciting things. We've got 2 of them in total, so I hope after what we're going to look at here, you get some understanding on some of the trig that has been challenging you. So this one is actually an identity question that says to us, we need to prove that the sine of x plus the cosine of 2x minus 1 divided by the cosine of x minus the sine of 2x is equal to tan x. So it's actually a question that requires us to prove that one side of this is equal to the other side, right? So the procedure of proving identities is the following. You're always going to pick one side that has got more information that you can simplify. So here's what you guys need to understand. There will be 2 sides. Some side equated to another side. Like something on the left equals to whatever is happening on the right hand side. So rule number 1, you can never take anything from the left hand side and take it to the right hand side. That will be wrong. What you need to do is you need to simplify the left hand side independently as an expression. And then whatever you get must look exactly like what you have on the right hand side. Sometimes the left hand side does not have enough info to help you to get yourself to the right hand side. So you pick the expression on the right hand side, you simplify that until it looks like what is on the left hand side. But that's not always the case. Sometimes you find that you take one side on the left, you work with it, you simplify it until it gets you somewhere. But then whatever you have does not look like what you want on the right hand side. So stop there. It's not the end of the world, right? It's not the end of the world. Like now, we've got problems with corona, but relax. It's not the end of the world. So what you'll need to do is leave the left hand side as it is, go fetch the right hand side, and try to simplify it until it leaves you somewhere. Whatever you're going to get at the end needs to look the same. Once the left takes you somewhere and the right takes you somewhere else, such that somewhere is equal to somewhere else, then you have succeeded to prove that the left is indeed equal to the right hand side. So let's see what is going on with this one. Now on this one, I can see that I've got a lot of stuff happening on the left hand side. So I'm going to take the left hand side and try to simplify that until it looks like tan x. So I'm going to write left hand side is equals to the sine of x plus the cosine of 2x minus 1 divided by the cosine of x minus the sine of 2x, right? Now, when you have this kind of a situation, you'll notice that we've got something very exciting that we got introduced to as grade 12s this year. And that is the fact that a double angle can be simplified. Like on the numerator, I've got the double angle of cos there, which can be expanded in 3 different forms. So the first one is you can write it as cos squared x minus sine squared x. If you don't pick that format, you could use 2 cos squared x minus 1, or you could use 1 minus 2 sine squared x. Right, so those are 3 versions of the double angle of cos that you can pick. Now, the decision I'm going to make to choose which one to pick of those 3, right, is based on the fact that I want to choose the one that will help me to delete that minus 1 you see on the numerator. So I want the version that will help me to remove this minus 1, right? That's the first guidance or the first clue that helps me to decide which one I'm going to pick. So I want that minus 1 to disappear. The second one that I'm going to actually use as an idea of which of these 3 versions do I need to choose is the following. I need to get myself to tan x, right? We're trying to prove tan x. And if you guys remember, you will be able to remember that tan x is as good as the sine of x divided by the cosine of x. So whatever version that I'm picking here, it is wiser to pick the one that will give me sines on the numerator, because I want to have sine on the numerator and then have coses on the denominator so that I can have sine over cos, which will give me tan. So of these 3 versions, right, the best one to pick has to be this one, the last one, the one of 1 minus 2 sine squared x, for 2 reasons. Number 1, it has a plus 1, which will remove that minus 1. Number 2, it is in terms of sine, so the numerator will be sines, and then I'll be able to get my tangent from that. And then on the denominator, we've got another double angle. On the denominator, we've got a double angle of sine. But that one we all know has got only one way of expanding it, so it's not a problem to decide on how to rewrite that one. So the problem is always the double angle of course, so always check how the question guides you. If you don't know what to do, don't rush, relax, expand everything else around that, simplify everything else, and then you get back to that cos 2x later when you've got more information that will help you to understand which one of those three versions to pick. So let's see what will happen. I've got sine x, I'm going to rewrite that sine x, and then there's plus, I'm rewriting that plus. Now that double angle of course, I'm expanding it, I'm going to write it as 1 minus 2 sine squared x, and then minus 1 divided by, on the denominator I have cosine of x minus, now that's a double angle of sine which can only be expanded in the form 2 sine x multiplied by the cosine of x. Right, now once we have this, you will notice that on the numerator, the 1 will remove the 1. This 1 here will subtract that 1 out. That will actually leave us with just the sine of x minus 2 sine squared x divided by, on the denominator, I still have the cosine of x minus 2 sine of x multiplied by the cosine of x. Now, your trig is not existing in isolation, guys. It's always important for you to make sure that you remember your algebra as well. So if you look there, I'm now going to engage my algebraic skills by looking on the numerator. You'll find that you've got a common factor between sine x and 2 sine squared x. And the common factor there is simply sine of x. So I'm going to factor out sine x. I'm going to have sine of x into, when you factor out sine x in the first term, you'll be left with a 1. And then when you factor out sine x in the second term there, you'll be left with 2 and sine of x divided by, on the denominator, the common factor is cos. There's cos in the first term and there's also cos in the second term there. I'm going to factor it out. I'll have cosine of x into, when you factor out cosine out of cosine, you'll be left with 1 minus, and then on the second part, you'll be left with 2 sine of x as well. The beautiful information here, or the beautiful story here, is the fact that this one will simply cancel that one out, and then sine over cos will give you what you guys were looking for. So if you divide sine and cos, you'll simply get it to be the tan of x, and then we can then claim that indeed, therefore, the left-hand side is just simply equal to the right-hand side, and that brings us to the solution for that first part. So it's very important for you to understand how to expand the double angles and which one of those 2 or 3 versions of the cosine that you guys would need to pick. All right, let's go to another part of this trig question. Another exciting one. It says to us here, now we need to determine the general solution of the square root of 3 sine x equals to the cosine of x minus 60 degrees. Right, now this is actually a very interesting question. There are many types of questions you can get that involve the concept of general solution. You can get one that is straightforward, like the ones that you guys got when you were in grade 10, right? Or the ones that require you to use your double angles, maybe use your compound angles. There's a lot of possibilities when you're dealing with this. So the one that we're currently looking at here is a situation where we've got different ratios and different angles. When that happens, if you've got different ratios and different angles, you can either use the fact that there will be compound angles being used in that case, or maybe you might find yourself in a position where you need to divide both sides by cos to change it to make it to be a tangent. So let's see what we can do on this one, right? So if you check here on the left hand side, I've got the square root of 3, right, multiplied by the sine of x, and then that is equated to, on the right hand side, you've got the cosine of x minus 60 degrees. Now it is very challenging because you see we've got different ratios at sine and cos, and our angles are not the same. One angle is x and the other angle is x minus 60 degrees. Now, we know something about something such as what you see on the right-hand side. When you've got the cosine of one angle minus another angle, we can simply apply our knowledge of compound angles and expand this. Remember, all this information is in your information sheet or the formula sheet. So I'm going to say on the left-hand side, I've got the square root of sine x, and on the right-hand side, I'll use the expansion of cos to find what this is going to actually expand to. Remember, cos is always cos. So it's going to be cos of x multiplied by the cos of 60 degrees. If it's a minus, your sign changes to a plus. And then I'm going to have the sine of x multiplied by the sine of 60 degrees. Now, those are doable because that's a special angle there. I'll have the square root of 3, the sine of x equals to, now that is actually, cos of 60 is a half. This is a half. So I'm going to write this half before the cos of x because when we write terms in math, we always put coefficients before variables. So that cos of 60 is half. Allow me to put the half in front. I'm going to put half here, multiplied by the cosine of x, plus the same thing applies to the square root of 3 over 2. This sine 60 is root 3 over 2. So I'm going to write it in front as root 3 over 2 multiplied by the sine of x. Right. Now, once you find yourself here, it's always easy to move beyond what you see, because you always ask yourself one question: what do I hate about what I see? I don't know about you, but I hate fractions. So I look at this, I see there's got 1 over 2. It also has square root 3 over 2. I don't like the fact that it's got those kind of fractions. So to undo division, I'm going to multiply all the terms by 2. That will help me to remove all those fractions. Okay, cool. So let's see how that is going to pan out. So I'll multiply everything by 2. If you double the stuff on the left, you'll get 2 times square root 3 sine of x. If you double a half, you're going to get 1 cosine of x. If you double root 3 over 2, you'll just sit with root 3 sine of x. Right. Now, you will notice that they are friends here. We call them like terms in mathematical terminology. This guy is friends with that guy. So for me to simplify this, I want them to be next to each other. So it's wiser for me to subtract sine x on the left. But what you do on the left, you also need to do on the right-hand side. You guys call this transposition, moving something from the left to the right. The correct mathematical terminology is subtracting the same thing on both sides of the equation. So I'm subtracting sine x on both sides of the equation. Now you'll notice that that will help me to just have cos x remaining on the right-hand side, and on the left, 2 root 3 minus 1 root 3. We're not only subtracting sine x, we're actually subtracting root 3 sine x. Yes, root 3 sine x. That will give us only one of them remaining on the left-hand side. We had 2 of them. We're now going to be left with 1 root 3 sine of x. Right. Now, once I have this, I've got 2 ratios that are not the same, but the angle is the same. So every time you find yourself in this position, you can divide both sides by the cosine of x. What you do on the left, you need to do on the right-hand side. This is a good idea because sine of a cos will just give us the tan of x, and cos of a cos will give you 1. Then tan of x will just become 1 divided by the square root of 3. Now, when you are here, you can then find your reference angle because we asked you to find a general solution. So my reference angle on this question is going to be arc tan 1 over root 3. Pick up your calculator, type that tan, arc tan 1 over root 3 or 1 over root 3. Let's see what answer you're going to get. If I type shift and then you press tan and then you put a fraction there, you've got 1 divided by the square root of 3, and then when you press equal to, it gives you a value of 30 degrees. That is your reference angle, which is an acute angle. So my reference angle is just simply 30 degrees. So then you come here and you ask yourself one question: where will my solutions come from? Remember, we check on the cast diagram, we're looking at places where the tangent is positive. We want where tan is positive, and tan is positive in quadrant 1 because all of them are positive there, and it's also positive in quadrant 3. That's where tangent is positive. So one answer is going to come from quad 1 and the other answer is going to come from quad 3. So I'm going to say one answer comes from the first quad and the other answer is going to come from the third quad. Right. So now according to the first quad, we're going to then say x equals to 30 degrees because 30 degrees is an acute angle that lies in the third quad, in the first quad. And for quad 3, we're going to have 180 degrees plus that reference angle. But they said general solution, so we need to add k times 180 for tan, even here, plus k times 180 degrees because the period of a tan graph is 180 degrees. If this question was about sine and cos, I was going to say times 360 instead of 180. And then it means that even this part here is also going to become 210 degrees plus k times 180. Tell the examiner that k is actually an element of integers. Very beautiful question indeed. I hope it helped you to see a lot when it comes to trigonometry. We did an identity question that involves double angles, that also involves compound angles in our general solution question, and I hope it opens up your eyes a bit so that you can see what is happening when it comes to this.